Hey, welcome to our video on similar triangles. There's some really neat stuff going on in this video. We're talking about, you guessed it, similar triangles. The definition for similar polygons, which I have on the screen, is the same as the definition for similar triangles. So let me refresh your memory on the definition for similar polygons. It just says corresponding congruent angles, and it has corresponding sides are proportional. And don't forget, this is the symbol for similar. We know that all corresponding angles are congruent, and we're looking at the marks. And then we also know that 5 to 10 is 1/2, 2 to 4 is 1/2, 3 to 6 is 1/2, and 1 to 2 is also 1/2. So we have a similar polygon here. Well, let's look at these triangles here. If we're talking about similar triangles, we could really just scratch out polygons and put triangles. And this would be the definition for similar triangles. They have corresponding congruent angles, and they have corresponding sides that are proportional. And the symbol for similar triangles would be that symbol right here. Let's look at what we have. These congruent marks for the angles are a little bit different than what were used in the previous slide. The congruent mark for the angles back here talked about this angle is congruent to this angle, and so forth. But when we start getting into putting 4 marks here, that starts to get to be a little bit of a cumbersome. And if we went to, like, say, an octagon or a decagon, if we were to prove the angles were congruent with 8, 9, 10 congruent marks, that would get a little tedious. So this right here, you notice how they all have one line marked in them? But then the dash means that those 2 angles are congruent. And then this double dash means that these 2 sides, or those 2 angles, are congruent. And then you also have the triple dash. And I understand if you have an octagon or a decagon, putting 9 or 10 marks in there would also get tedious, but this is also a different way to show that angles are congruent than what we used in the last slide. So we know that all corresponding angles are congruent. Now let's look at the corresponding sides. Well, 18.4 corresponds to 9.2. 18.4 over 9.2, that's equal to 2, or 2 over 1. Let's look at 20.8 compared to 10.4. 20.8 over 10.4, there you go, 2 over 1. And then 5.4 and 10.8. Well, since 20.8 and 18.4 both went on top and they came from the left triangle, 10.8 has to go on top from the left triangle. And 2. So if we look, they all have a ratio of 2. So therefore their corresponding sides are proportional. In this example, it says in the diagram, triangle ABE is similar to triangle ACD. AD is equal to 42, and it wants us to write a statement of proportionality. Statement of proportionality just looks at side AB compared to side AC. So if we're going to say AB over AC, and then let's look at AE over that whole side. We went, AE is the right side of the small triangle, and AD is the right side of the large triangle. AB went on top, so AE is from the same triangle that AB is from, so it goes on top. AD and AC are from the same triangle. And now what we're doing is we're creating a statement of proportionality to show that sides are proportional. And it's real important that we keep the sides from the small triangle on top and the sides from the large triangle on bottom. And you might ask, do I always have to put the smaller triangle on top? No, you don't have to. We could have, let me cross this off for a second. We could have put, at the very beginning, we could have put an AC on top, and then AB would have had to go on bottom. But also remember, if AC goes on top, then AD would have had to go on top. And CD would have also had to go on top. And so we have the sides from the large triangle on top, the sides from the smaller triangle on bottom. And so either one of these is a statement of proportionality. You just have to keep the same triangle sides together. So let's move on to the second question. Find the measure of ABE. Well, if we're trying to find the measure of ABE, it goes back to the definition of similar triangles. Definition of similar triangles, or similar polygons for that fact, says corresponding angles are congruent. So ABE is right here. So what is that angle measurement? Well, ABE corresponds to ACE in the large triangle. So since ACD is 68 degrees, the measure of ABE is 68 degrees. And the directions right here told us that A to D was 42. So we're supposed to find AE and ED. Well, we go back to our statement of proportionality. We know BE and we know CD. And so if we look here, BE over CD is equal to AE over AD. So BE is 7, CD is 28. And so now we know that AE is what we're trying to find. And what is corresponding to AE? AE is the right side of the small triangle, the right side of the large triangle, AD. So we're using this fraction in the statement of proportionality. AD would be 42. Okay. All right, so now all we have to do is solve for AE. I'm probably doing some cross multiplication here, but 7 times 42 and then divided by 28, I'm not real interested in doing that because 7 times 42 is something like 294, and 294 divided by 28. What we can do here is 7 over 28 will reduce to 1/4. So now we have, instead of 7 over 28, we have 1 over 4, and I can tell you that 1 times 42 is a lot easier than 7 times 42. So 1 times 42 gives us 42, and 4 times AE gives us 4 times AE. How do we get AE by itself? Divide by 4, divide by 4. And what is 42 divided by 4? Well, I know 4 goes into 42 10 times. There would be 2 left over out of 4. So that's what AE is equal to. But you can reduce 2 over 4 to 1/2. Oh my, look at that. That is a good picture right there. AE is 10 1/2. That's just marvelous. All right. So, well, we found AE. We need to find ED. So let me go ahead and erase some of this. If you need to pause the video to catch up, write that down, go ahead and do that. But let me go ahead and erase some of this. Okie dokie. Now, well, we know AE is 10.5 or 10.5. Or you could have had 21 over 2. I think 42 over 4. 42 over 4. Divide each one by 2, you get 21 over 2. So either one of those three answers is sufficient enough for AE. Now we need to find ED. Well, ED is, once again, we know BE over CD, which is 7 over 28. Okay, bottom of the small triangle, bottom of the large triangle, 7 over 28, so that's 1/4. Let me write that up here. 1/4. Now we need to find ED. And I'm completely not even looking at the picture. Oh, can you believe that? Well, if we know AE right here is 10.5, we know the whole thing is 42. That would be, the whole thing would be AD. So AD, and we use the segment addition postulate because AE plus ED will give us AD. And so let's plug in some values. We know AD is 42. We know AE is 10.5. That's why you should always look at the problem and understand what you're... I didn't even need that fraction. 7 over 28. Not for this one. So how do I find ED then? Well, trying to get ED by itself, we subtract 10.5 from both sides. So subtract 10.5. ED is going to be, well, 42 minus 10 is 32, and 32 minus the half, 31.5, 31.5. So ED is 31.5. There we go. Some things you're going to have to remember. Statement of proportionality. That's just creating the fractions there using the vertices of the triangles. And I think the rest of it, you should just be able to use your algebraic skills, your critical thinking skills to come up with it. ED is 31.5. Okay. Man, we are rolling. Rolling. The angle similarity postulate. Well, you might say, this kind of looks like side angle side, 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 side. What are the other ones? Angle, side, angle. Or, what's the last one? What's the last one? Are you sure? Yeah, I think you got it. Hypotenuse like. Well, what do these 5 postulates and theorems do? What do? They prove triangles to be congruent. What is the angle similarity postulate doing? Well, it's proving triangles to be similar. So you cannot get these two things confused. This is congruence. You have to have that memorized, that those are congruent, because we're also going to have 2 more similarity postulates after this section. So you're going to have 5 postulates and theorems that prove triangles congruent, plus 3 postulates that prove triangles similar. So let's look at the postulate here. It says if 2 angles of one triangle are congruent, the 2 angles of another triangle, wow, then the 2 angles are similar. So if then the 2 angles, then the 2 triangles are similar. So if 2 angles of one triangle are congruent to 2 angles of another triangle, then the triangles are similar, which means that the 3rd angle will be congruent because of the definition of similar triangles, and then all sides will be proportional. So which angles do we have congruent here in this picture? Well, you might want to say angle B is in both of the triangles, the little triangle, and it's also in the large triangle. I mean, you guys are right on top of it now. And what's the other one? What is the other one? Parallel. What's that mean? Corresponding angles are congruent. So right there we have the angle-angle similarity postulate. Angle B in the small triangle is congruent to angle B in the large triangle. And then angle BDE in the small triangle is congruent to angle BAC in the large triangle. So therefore the two triangles are similar. And that's almost as good as the Yahtzee. Well, minus the 50 points. How about this one? This is these two triangles are also similar through angle-angle. So can you figure out what's the two angles that are congruent? Well, we have no parallel lines, but we do have these. Those would be right angles. So, but those aren't congruent angles yet. But you do know from a theorem earlier in the year that all right angles are congruent. So we know angle A in the small triangle is congruent to angle D in the large triangle. What's the other one? What's the other one? It's almost like finding Waldo. Have you found Waldo yet? Where's Waldo? Right there. Angle ACB is congruent to angle ECD. Why? Why? Can I get a vowel? You sure? You want a vowel? Oh, there's 250. But what's the next one? Man, you got it. Vertical angles. That's why the two angles here in the center are congruent because of vertical angles. Okie dokie. And here's one more example. Parallel lines. Anytime you see parallel lines, you should be thinking alternate interior angles are congruent, alternate exterior angles are congruent, corresponding angles are congruent, and same side interior, or also known as consecutive interior, are supplementary. So looking here, we have two sets of parallel lines, and we have parallel lines cut by a transversal, making corresponding angles congruent. Parallel lines cut by a transversal, making corresponding angles congruent. Let me go ahead and clean this up a little bit for you. And go ahead and put our congruent marks back in there. Let me color code some things here for you. Because those two triangles are kind of overlapping there a little bit, might have been a little hard for you to see the angles that are congruent in the small triangle compared to the angles that are congruent in the large triangle. And there we go. Two angles in one triangle congruent to two angles in the other triangle. Triangles are congruent. Okay, so let's look here. I would like you to determine the length of FG. Well, in order to determine the length of FG, you know that those two triangles are not congruent because 10 and 16, or I'm sorry, 10 and 6 make 16, and on the very top, 15 and 25 make 40, so therefore sides are not congruent. So are the triangles similar then? And if the triangles are similar, we can maybe think that their sides are proportional. Similar. Well, we know angle, angle. So which angles would be congruent? Well, we need to look at FG. FG is part of that triangle right there. Now, there's three triangles we have to look at with FG. There's this right triangle, There's also this smaller right triangle, but then there's also this larger, I'm going to say scalene. It looks scalene. So there's three triangles right there that FG is a part of. But remember, we need to prove two sets of angles to be congruent within triangles. Now, we can use the right angles being congruent. Right angles being congruent. And that is not part of that large triangle. Okay? That right angle is neither of these three angles that's part of the large triangle. So we have right angles congruent, and do you need a vowel? I think I did that wrong. But when I said you need a vowel, you might be thinking, I don't need a vowel, I'll take a V for vertical angles. And so now we have vertical angles congruent, we have the right angles being congruent, so therefore we know that, let me put some letters here, let me put like A and B. So therefore we know that triangle AGF is similar to triangle BHF. Yeah, okay. But just letting you know, there's a prize for those that have initials of AGF or BHF. If your initials to your name are one of those three, come on down, because you've won the grand prize, and you'll figure out what that is when you get down here. No? No takers? Nobody with the initials? No? No takers. Okay. All right, well, let's get back on to looking at these two triangles. Well, let's look at these two triangles. Let me get a color that you can see there. So we have this triangle here, and we also have this triangle here. We're trying to calculate FG. FG is this unknown side. Well, a statement of proportionality is going to say FG over top of FH. FG is part of the smaller triangle. FH is part of the larger triangle. So we say FG over FH is equal to, well, AG is part of the smaller triangle, which is the same triangle as FG. And FG is down here. I'm sorry, I said FG and I meant AG. AG is down here. HB is, you know, the corresponding side of the larger triangle. So AG corresponds to HB. Just pretend like that didn't happen. All right, so now we just, FH and HB are part of the same triangle, so therefore we have things lined up. So now let's plug in some values. Well, FG is our unknown. FH is 10. AG is also 10. HB, 25. There we go. Now, we could reduce 10 over 25 to be 2/5, but I'm going to tell you this right now. 10 times 10 is 100 to cross multiply, and x times 25 is 25x. And you should know what 100 divided by 25 is fairly quickly. Sometimes I'll reduce, sometimes I won't. In this case, I'm not reducing 10 over 25 because right here, 100 divided by 25 is 4. That's an easy number. If you've ever bought bubble gum from a bubble gum machine, you're usually using quarters. And when you go get a dollar bill changed out, you get 4 quarters in it. There you go. X equals 4. Well, what is X? FG is 4. And if we look, FG, or FG over FH is 4 over 10. which equals 2 over 5. AG over HB, 10 over 25, which is 2 over 5. So therefore, the corresponding sides of the triangles are proportional. Alrighty, well, let's keep on trucking here. We have done well so far, and I put this one with invisible ink. Just kidding. Just kidding. This is the end of this lesson. I appreciate your time, and we will see you on the next round.